The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Your host here, Eric Cavanaugh, and what a fun show we have today, folks. A few veterans on the call. We're going to hear from the software side, from the practitioner side, and all kind of fun perspectives. We're going to talk about machine learning and how to optimize these algorithms. How do you optimize the predictive capability from your analytics solution? A lot of factors come into the equation. Obviously the data, obviously the algorithms, the compute, the ability to bring all this stuff together. But there's a lot of thinking, a lot of creativity that goes into this. And I'll quote one of my favorite developer friends, my good buddy Everin Chucker, who once said that busy is the enemy of creative. And I love that line. He's basically saying, if you're just busy all the time, well, there may be something that you should change about what you're doing and how you're doing it. So in the world of predictive algorithms, I mean, this stuff is now everywhere, folks. It's baked into all the major platforms that you're using, Amazon for sure, Google, but other platforms, Facebook, LinkedIn, Instagram. There's all sorts of machine learning algorithms in the background, just kind of trawling around and cranking away and doing some number crunching for a number of really important aspects of our daily lives from a business perspective, of course, like customer churn. That's one of the long-standing use cases around analytics. What is the behavior pattern of someone who is about to say bye to AT&T or Verizon, for example, those telcos worry all day long about customer churn, and they're constantly trying to track behavior of their customers to figure out when someone will churn. So one of the cool things you can do with this technology is you can look backwards, basically. So yeah, we want to predict forwards, but we want to look at behavior in the past. So one of the tricks you can do is look at all the people who left. Those are the people who churned. Well, let's find some patterns of behavior amongst those people. Like, for example, they had a few dropped calls, or they had some surprise expenses on their bill, some line items they didn't expect. Various things of that nature. That's a problem. So they're going to be upset about that. And what you could do is identify these patterns, and then going forward, build models to watch for them, and then insert some action to say, uh-oh, looks like Bob is going to leave. So let's throw him an offer. Let's give him a discount. Let's do something to build that trust back and get them on our side. So customer churn is one. Fraud detection. We'll hear about fraud detection today on the show as well. That's a huge one. Look at all the hacks these days. The bad guys are everywhere. It's kind of amazing how much traction they get. You have to be careful what you click on in your emails these days, because there are all these phishing attempts. So that's another big one. Next best offer is one of the more common ones we hear about. What will this person also want to buy? So point is, there's lots of different ways you can do this. Our guests on the show today are going to tell us about that. And so let's go ahead and dive right in. We have Kathleen Maley, a Chief Analytics Officer and VP of Analytics over at Experian. We'll talk to Tim Wyatt from Lookout and also David Sweenor from Alteryx. But first, Kathleen, tell us a bit about yourself and what you do in the analytics space, and maybe some lessons that you've learned about optimizing predictive capabilities.
Yeah, sure. So I started as a risk modeler. That was my job, was to predict the risk of credit applicants and credit customers. And I was doing that in 2007 and 2008. So that was a really exciting time to learn how to do that business. If anybody remembers the crash. My background is actually statistics. I have a master's degree in applied statistics. And you know, what I've done over the last 15 years of my career is work mainly in the area of analytics, investigatory analytics, exploratory analytics, the predictive modeling, certainly the machine learning. But where I got really excited about a few years ago was a deeper understanding that I can do all sorts of wonderful things with algorithms, but if a business isn't able to ingest those algorithms, to put those algorithms to work, they don't actually produce any value. And I sort of put my business leader hat on, and I thought, if I develop a B+ model in 6 months instead of an A- model in 18, I'm actually going to deliver a whole lot more value for the business with that B+ model, iteratively build that improvement in, and sort of move forward that way. So we're at this really interesting stage, I think, of, we have this practical application of analytics, and we've been figuring out these problems that we've been struggling with, totally focused on the algorithms themselves. But now we've got sophisticated technology that allows us to use a lot more data, to process it much more quickly, to use more sophisticated algorithms. But now it's got to be about, okay, but what are we actually doing with it? And what are some of the new edge problems, right? Machine learning algorithms do not create bias. A model is a model is a model. They're dumb. They're all dumb. They're just dumb as a computer. They're dumb. They can only do exactly what we tell them. It's all about how we are putting these things into production, the decisions we're choosing to make, how we're using and creating the data that feeds into them. It's hugely complex, but when we start applying these algorithms to real world problems, there's a whole new set of challenges that have to be addressed to be able to use them effectively. So that's a lot of what I do now. It's still a lot of what I do is in the area of education. How do you actually use this stuff? What is it really? But how do we use it? And what are some of the watch items around it?
Yeah, that's fantastic. And you really, you just made my heart sing there with that comment about algorithms not being biased. I remember when I first read this article saying, I'm like, guys, come on, like algorithms cannot be biased. People can be biased. You can bake bias into an algorithm by virtue of how you design it, or by virtue of the data that it feeds upon. Remember, wasn't it Microsoft's AI Twitter handle, Tay, I think, was just after like a day was spewing out all these epithets. And they're like, whoa, what's going on? Like, well, guess what? It's gathering information from the source, and it's just taking that information and making decisions. So it's almost, the algorithms are almost like kids without brains, right? They'll repeat after you, but they can't think through stuff, right?
I think that's a great way to put it. And it's, in a way, I guess it reveals a lot about ourselves. It reveals a lot about how we're developing these things and magnifying some of these issues that exist elsewhere. But the algorithms themselves aren't causing the bias. And in fact, I would argue if we're using them in the way that we can use them, we can use them to eliminate bias. Yeah. It's not easy. It takes real thinking and intelligence and intention. Right. But the algorithms can remove bias as well.
That's fantastic. This is really good stuff. I'm really glad you mentioned that, because it's such a hot topic. And obviously we want as humans to watch out for bias, and we all have our own biases. I mean, that's not anything new. We've known about that for a long time, but sort of understanding your own personal bias is a difficult thing to do, because you are you and you are subjective about yourself. And I think that's one of the things we need to understand as we train. And we'll talk to David Sweenor from Alteryx later about upskilling. And that's one of the skills to learn, I think, is to take a step back and try to understand your own influence on the work that you do and the algorithms you design and what they do, and just have some processes around that. Right, Kathleen?
Absolutely. Watching, once it's in place, monitoring it, what is actually happening, what is it actually doing, and adjusting on the fly. I think that's the other reason why I'm a huge fan of experimentation. So we can create data, right? If I'm building, here's a classic one, right? In the very early days of facial recognition, it worked brilliantly as long as you were a white male. Because of course that was the data that was used to design these algorithms and on which these algorithms were trained. Right. Well, okay, taking that concept a step further, I can actually design my training data sets to address problems that I already know I'm likely to encounter, and then monitoring what is happening once it's live for all of those questions I didn't even think to ask at the beginning. But once I know to ask them, now I can redesign my data set. I can go and either create the right data or capture the right data and build it into the algorithm to create an intentionally more comprehensive set of data for whatever business problem I'm trying to solve.
Yeah, that's a great point. And maybe I know later in the show I want to talk to you about team building, and since you built teams and run teams, how to do that. But I'll throw one curveball at you first before we bring in our next guest from Lookout, Tim. I want to talk about how how you're able to deal with significant environmental changes like COVID, for example. With all these predictive algorithms about consumer behavior, and almost everyone I talk to says almost all of them went right out the window when COVID came along, because so much human behavior changed. How often we drive, what we buy online, when we buy online, what we don't buy in the store, what we do buy in the store, all these things changed. So that's a significant disruption. How do you deal with that from an optimizing perspective of predictive analytics?
Yeah. So if somebody has a better answer, I would love to hear it. But back to kind of your opener, which is models are built on historical data, period.
Right.
It's funny. Why do we call them predictive modeling? They don't actually predict anything. They tell you, they explain what has happened historically under a certain set of conditions. Well, as those conditions change, my outcome may or may not be the same. And so it's really hard to sort of forecast out, right? You can't actually tell the future, but I think this is where newer technologies are so valuable. In the old days, it would take months to build a model, usually a very traditional approach. The time it took just to process data was so long. I literally could not run optimization problems because I didn't have the compute power to run that many different scenarios, right? So if I wanted to optimize a decision, I maybe could do that once a month. That is no longer the case. We can process huge amounts of data very, very quickly. It introduces a new set of challenges. How do I make sure that that is a controlled system? It can no longer be human dependent. I have to have an automated mechanism with control points that allow me to review what is happening. The other thing I'll say is, and this is a huge, huge learning for me, and one of the best ideas I've ever had in my career. I don't think I'll ever have another one. Honestly, this was right around 2015, 2016. I was working on deposits pricing. Well, deposit rates had been very, very flat and near zero for 10 years. And we were trying to build price elasticity models. Now, if you know anything about data, you know that you are not going to be able to design a good model if you have flat data. You need the variability. And so the question was, what do we do? Well, we said, let's take a more econometrician's approach. Let's think like econometricians. What is the data we think is going to matter? Let's construct an equation that incorporates all of these variables. Let's manually set any of these variables, the coefficient to these variables, to zero, because they're not predictive today, but they might be predictive tomorrow. And so every week, every month, I can run new data through my equation. If these new coefficients, right, become non-zero, then I can decide, is now the time to introduce that variable or not. No recoding, no taking it through legal risk and compliance. The equation is there, the mechanism is there. It's just about running the data through with control points to say, do I want to flip the switch and now reintroduce this variable or not? Wow. And it was a way where we could just very, very rapidly, as rates began to rise, that was essential, because the minute rates began to rise, my model would be irrelevant.
Wow. That's very clever. Let me just explain that to our audience. So basically, Kathleen realized, look, we don't want to have to recast the formula. So we'll create the formula with lots of null values in it. And then as something changes in the market and some particular factor or facet becomes significant, we just start populating that value. So so you don't have to rewrite it. You just have to enter some new information. That's really, really cool. We only got a few minutes left in the first segment. Let me bring Tim Wyatt in from Lookout to kind of comment on that. Tim, you've been in this industry for a while, and obviously you focus on fraud. You were telling us before the show, but that strikes me as a very clever solution, a very elegant solution to a very complex world. What do you think?
I mean, I think my expertise are in a very, very different set of applications from that. I certainly think that intuitively, if you have if you are trying to predict processes that can be very volatile in different circumstances, you have to be willing to partition your data sets around those kinds of things and look at the characteristics in a changing way. I certainly can't, as you were saying, imagine predicting volatile pricing processes with a very long-term flat data set. I can't imagine taking slices of time with different characteristics and building models that can be applied in different circumstances. That is something. That is something that we have a tendency to do is kind of build different models that are tailored to different pieces of data that we're interested in, and then kind of try to build ensembles around those things as well, which strikes me as somewhat similar.
Yeah, that's a good point. And just to kind of flesh this out for our audience, ensembles are very popular these days. And the idea is that you have a number of different formulae that you kind of bring together and aggregate in some meaningful way, such that you're not going too acute or too obtuse. It's a way of sort of balancing things out. But the bottom line, and I'll maybe get you to comment on this quickly before the break, Tim, but as Kathleen said, these days you have the compute capacity that you didn't have 5 and 10 years ago. So all these factors are changing what's possible and thus how we should do things, right?
Yes, absolutely. I mean, we're able to work with tremendous amounts of data today, and particularly with the various very large scale cloud platforms that we have to work with. There's you can get as much compute capacity to solve problems as you can afford to purchase.
Yeah, and you can. I mean, it's beautiful because we have this real scalability today that we did not have before. You can scale up and then scale right back down for peak periods or when you want to test something. So you don't have to lock yourself into predetermined packages. And that's a really big deal. Well, folks, don't touch that dial. We'll be right back. We got an all-star cast for you today. Kathleen Maley from Experian, but also she's got her own outfit that she runs. We've got Tim Wyatt from Lookout and David Sweenor up next in a minute from Alteryx. I'll come back to Tim Wyatt to tell us a bit about his experiences. And Tim, I know you focused on fraud protection and on really preparing data sets. That's one of these huge issues that is very challenging to sort out and to get good at. And I'm guessing the deal is you're always hopefully getting better at it, but you can never perfect something like that. What do you think, Tim?
Sure. Yeah, I mean, our goal is to build data sets that are, our primary goal is really to protect our users. And one of the most important things that we do in order to do that is we hunt for threats. We hunt for threats in software that people are running. We hunt for threats in content on the open internet. And these are very large, these are very large piles of data. They're very large haystacks to try to go hunt through, right?
Yeah, right.
The research teams that do this kind of work, I don't think that you will find a security organization out there that thinks that they actually have enough threat analysts to hunt through the piles of things that could be possibly targeting their users and find everything. It's a very difficult problem to solve. So, the approach that we've taken to doing that is trying to build data sets that we believe will be predictive of, or that will put the right information on the table for us to go through, and then try to apply analytics and machine learning to help us sift through those data sets. It's very, very much a tool built to assist human analysts in hunting for things, built to assist automation processes for detection purposes. There's a lot of art both to building the data set as well as applying the analytics on top of that. And then, kind of similar to what Kathleen was talking about, if you, there's an awful lot of stuff that has to go into how you actually apply that. I think one of the things that I see a lot, just in terms of kind of the public-facing conversation, there's a lot of organizations that are talking about all the research that they are doing into machine learning, and less about how they are actually applying it and all of the processes that you wrap around that. And I think you can very easily spend a lot of time doing research and building models that you don't actually put into practice if you're not willing to put the time and the energy behind things like ML ops, which we were talking about before, in order to kind of automate and build regularity to the processes of providing feedback loops and refining models, but then also building like real software systems that are putting things into practice.
Yeah, that's good stuff. And the beauty of having an environment where you capture all that information is that you can go back and figure out, hey, look, it turns out that Susie is really good at identifying problem areas in the data sets, right? As long as you capture everything, you can go back and keep an open mind and optimize over time, because you will get good at things, and different personalities are good at different tasks. This is something I've learned a long time ago. And let's bring in David Sweenor from Alteryx. And David, this is great because I get to quote one of the most clever people I met in this industry, Maureen Clary. Years ago, you may have met her. She used to run Connect, the Knowledge Network. And she made this really good point to me. I listened to her give a presentation. She said, and this is probably 12, 14 years ago. It's actually before DM radio. It must be 15 years ago. She made this really good point. She said, in the United States, we tend to focus training around areas where people are not very good. So if someone's not good at math, we'll send you to math class. If someone's not good at communication, we'll send you to communication class. And her point was, don't do that. No, focus on your strengths, figure out what someone is good at, and then help them get better at that, and just make sure their job is focused around that, which I thought was really interesting, because the other old model is, let's make everyone the same. If someone's bad at math, let's really just break the bank to get them good at math, and they just don't like math. But what do you think about that in the context of this conversation, David, and the context of upskilling?
Well, it's interesting that you bring that up. I had a psychology professor that said the same thing. He said that essentially, if you think of a person like a rubber band, you can only stretch them so far. So let them focus on their strength, because if you want them to focus on math and they don't like it, it's going to break eventually. Well, they have to have some basic knowledge of that. But I think, upskilling is a huge topic in the analytics space. And so just a bit about my background. I started out in high-tech manufacturing, so semiconductors. And for people who don't know what they are, it's a 300 millimeter disc where I was, like a record. I might be aging myself, about that size. And this takes 6 to 9 months to build these things, right? So it takes quite a long time and go through 1,200 different process steps. And if you think about the data that emanates off this, there's image data, there's categorical data, there's process data, measurement data, and their disk. So you can get spatial patterns when you test these. So you can, and these really indicate specific different kinds of failure modes and equipment that might be causing these. So I was in a factory, right? And so I'd walk and say, hey, how do you solve this specific problem? And this group of people, the characterization engineer, said, hey, we solve this way. And then I would walk over to the test area. It's like a 20-minute walk across the campus. How do you solve the problem? This group solved the same problem a very different way. Then I would go walk over to the quality group, and I said, well, how do you solve the same problem? Well, they solved it a very, very different way. And so, what I thought there, it really got me thinking is, how many times do we need to reinvent the wheel? There was no sharing of best practices or anything like that. There was no central repository of analytic algorithms, models, dashboards, reports, data connections, anything. And, I read a recent stat that said, 93% of projects fail, not because of technology, but it's because of people and process issues. So, earlier it was brought up that, we have teams of domain experts, and really there's two approaches that I've seen companies adopt, right? There's the big bang data science team, and they're going to work on some of these really high value problems that organizations have. And then, there's another approach where maybe a business user, an analyst who might not be trained in data science, maybe they're an accountant or what have you, they have a lot of knowledge about that space. And so, our organization is really focused on software that can help an analyst make use of data and analytics. And, I think this notion of upskill is hugely important to the entire industry, because, if you can't get the right insight to the right person or insight at the right time or system at the right time, then, you're sort of wasting your time. And, I tell a lot of people, hey, we want to do predictive analytics. They say this, I'm like, this is great. And like, what are you going to do if you can predict something a minute, 5 minutes, 10 minutes, an hour, a week into the future? And they're like, well, I don't know. So if your business process doesn't change, if your business can't change as a result of this prediction, then what are you really doing?
Right.
And I think organizations need to step back and think about that before they say, hey, I want to do AI or machine learning or whatever term du jour you want to use. And so, but, making sure that the people who are creating the analytics and know the business space and have a way to you leverage data and analytics to solve real business problems that they're having, I think is hugely important. And so I think most of our companies that we work with, they do both. We have a big bang data science team. They're focused on high value problems, but there's a lot of small problems in every functional area within a business that non-trained experts like myself could solve.
That's a really good point. A lot of small problems, and it's all about workflow. And we kind of hinted at automation earlier in the show, and really this is the future. I mean, if you look at the companies that are just killing it today, they have really thought through business processes and workflows, and they've found those control points, to use a term from the risk management world, where they can insert that predictive capability. Like we mentioned customer churn, for example. Well, how do you tie your communications program into your customer churn program, right? There has to be some nexus, some control point where it gets handed off. Does a person approve that? Is it automatic? Is it dynamic? That all depends. I think ideally you want to be as dynamic as possible, but you sure don't want to over automate too soon, because getting back to Tim's point from earlier, you want that human in the loop to be watching things and to have the kill switch, right, David?
Yeah, absolutely. If you look at the spectrum of decisions that can be made in the organization, there's decision types, I should say. There's like fully manual to fully automated. Let's just say there's 5 categories of these. The fully automated, that's a small percentage of decisions. All of the rest of them, whether it's human-led or machine-led, there's usually a human, that can either override or is making the ultimate decision. I don't think any of us want a robot making a medical diagnosis for us. Right. So they might make a recommendation, right, but your doctor is going to he's got the expertise, and or she has the expertise, and you want that sort of comfort level there.
Yeah. And believe it or not, folks, Shazam, which almost every kid has these days, I have it. I think it's about the coolest app ever. If you don't have it, you got to get Shazam. Shazam actually got a song wrong the other day. I was like, oh, holy cow, they actually got it wrong. It's the first time ever that they got a song wrong that I was Shazamming. And yes, I sent it back. Nope, this one's wrong. So there's some database somewhere that grabbed that information. It's going to be used to prevent that from happening again. You can't have Shazam get things wrong, folks.